Hello everyone, welcome back to a new video. In this video, I will try to create a definitive guide to install IoT View on a Raspberry Pi. The IoT View runtime is one of the runtime versions of AVEVA Edge. It's the version of the runtime that it can be installed over Linux, and it's a very small footprint, so it's for basically IoT View applications. And some people, I received support requests from people trying to install it, but they fail. So I wanted to create this guide to help in a visual way to anyone to be able to install IoT View successfully. So right now I have my computer connected. I'll plug it in my micro SD card. It's a 32-bit micro SD card, 32 gigabytes, sorry. And I have here my Raspberry Pi Imager tool, which you can download from the Raspberry Pi official website. So it allows you to create SD card with the OS inside. So I would choose the OS, which is the 32-bit Raspberry Pi OS. And I would choose the storage, which is my micro SD card. And I will click on write. So as you can see, I'm starting from scratch right now. I have nothing, right? I have nothing on my micro SD card. By now, I will have the Raspberry Pi OS, a fresh installation of the OS. So you can see how IoTView can be installed from nothing. And it's not so complicated to do it if you follow the correct steps. So while the writing is being executed, I want to start the AVEVA Edge to show you a couple things. The first thing that I wanted to show you, so let me put it in my other monitor here. First thing that I wanted to show you is that we have a manual to install a IoT View. So if you go click the help, the technical reference will be open. And if you type, for instance, the OS that you are going to use, Ubuntu, it will show you the guide to install IoT View on Ubuntu. And if you want to install it on a Raspberry Pi, type Raspberry, you will find the guide for the Raspberry Pi. So all the steps that you need to follow are here. And this is basically what I will be doing today. But you will see how all this is done. So it's basically this guide. This guide is very, very complete. So that's the first thing that I wanted to show you. The second thing that I wanted to show you is that you will need to create a new project to send the project to the Raspberry Pi when IoT View is installed on it. So to create a new project, please make sure that you select the correct target system or product type here. The product type should be embedded because the IoT View runtime is considered also an embedded runtime. So please don't select the Windows one. Don't select the Windows product types. Select the embedded ones and the one that will match with your IoT View license. So I will select the smallest product type, which is embedded by AVEVA Edge 150 tags. That's it. My project will be called IoT View demonstration. Yeah. Well, the resolution doesn't matter so much. I can put a smaller resolution just because I'm doing a small application. But it doesn't matter. You can put any resolution anyways. I won't be using the security system this time. I will plan to do a video about the security system because in any of my videos I use the security system. So some people might be thinking about what the security system is. While the installation on the Raspberry Pi SD card is being verified, I have my IoT View project created on the IDE. So we just need to wait for the verification to finish so we can continue. You can skip the video for 30 seconds maybe. Okay, the verification completed and the Raspberry Pi OS was writing on the SD card. So if I click on continue and close this, the SD card was already ejected by the tool. So I will open the Files Explorer. I will disconnect and reconnect the SD card. And I have now two partitions. This is the Linux partition, which contains the OS. And this is something that we won't use, and we don't have access on Windows also to that partitions anyways. We won't be using it. And this is the important partition. The boot partition is also on the SD card. And here we have some files that the Raspberry Pi OS and the Raspberry Pi uses to start to boot up. So one of the files, one of the useful things that you can do here is configure the Raspberry Pi without need to connect a monitor with it. I don't have a monitor for this Raspberry Pi right now that I have here on my desk. So I want to enable the SSH access from the boot app. So SSH and nothing else. This file will tell to the Raspberry Pi that SSH should be enabled during the boot app. And the other thing that I want to do is connect the Raspberry Pi with my Wi-Fi network. By the way, I'm using a Raspberry Pi 4, which has Wi-Fi. So I will connect it with my Wi-Fi network directly without need to use a keyboard or use a monitor with it. So I already have a file here, which is this WPA supplicant.conf. This has inside my network network name and password, and I only need to put the file here. If you need more information about this file or about this file, I recommend you to do a quick Google search. So you can maybe put here SSH enable Raspberry Pi SD card. Enable probably this tell you what to do. Create a new empty file name SSH without any extension inside the boot directory. That's what we basically did. So you will find the guide on the internet about this, the WPA supplicant. Connect Raspberry Pi to Wi-Fi SD card. And you will find maybe the first guide here. Sorry, we'll tell you how to do that. So here it's the WPA supplicant file, and this is what you should put inside. So you should put your network name and your password. That's what I have in my file. I don't want to open it because I don't want you to see my network name and the network password because it's my bank account password. Just joking, but I don't want to show it that. It's just this basically. So you can create it by yourself. You put this in a text note, save the file, change the name, change the extension from txt to conf. That's it. You can put that file in the boot partition of the SD card. So when the Raspberry Pi boots up, it will connect with your Wi-Fi network. Okay, so I will eject the SD card now, and I will connect it with my Raspberry Pi. So putting the SD card on the device. You cannot see right now what I'm doing, but I'm connecting the SD card with my Raspberry Pi. And I can see that it's booting up because the green light on the Raspberry Pi is blinking. And well, you might be wondering why, and now how you can determine the Raspberry Pi IP address. I found on the web some options. Some people say that if you do a ping for Raspberry Pi, it will reply with the IP address, but it depends a lot of your internet gateway and your router. If it can work as a DNS, well, that might work. But there are other options. You can use a network scanner to check all the IP addresses on your network, or you can simply directly check on your internet gateway what's the IP address for the Raspberry Pi. So that's what I will do. So this is my router IP address, and this is my user and password. Okay, so let's click on Wi-Fi devices. This might take a little bit. I don't know why, but it takes some minutes to populate a list of Wi-Fi devices. Seems like I have a lot of Wi-Fi devices connected to my home network. To be a home network, I have multiple devices. But anyways, let's wait for it to finish. So you can skip the video maybe 30 more seconds. Okay, maybe not 30 more seconds, but it's ready now. So I need to search for, oh yeah, here it is, Raspberry Pi. So for the Raspberry Pi, a host name, and this is the IP address for it. So I will copy the IP address, and what I will do is I will connect with a tool called PUTTY. One more time, you can download this from the official PUTTY website and install it. And after having it installed, you can open it, and it allows you to connect with anything that talks the SSH protocol. So I will put the IP address here, and I will connect with my Raspberry Pi using SSH. So I click on open. Something about security, I will accept the warning. And by default, it will ask for the user and password. The default user and password for the Raspberry Pi is Pi and user, and the password is Raspberry, I think. Yeah, that's the default user and password. It tells, okay, you might want to change the password, but well, I don't want to change it right now. So we are connected with the Raspberry Pi right now. The next thing that I recommend to do is maybe enable the VNC server, so you can connect and see the Raspberry Pi desktop. So to do that, I will do the sudo, I think sudo raspi config, and I will, come on, I will go to interface options, I think. Yeah, VNC. Oh, before that, I was missing one thing, important thing, display options. I need to change the resolution to something like this, maybe. And I will change now the interface options to enable VNC. Yes, I want VNC enabled. And finish. I want to reboot. Yes, I want to reboot. Right now, the VNC, sorry, the SSH connection is closed and my Raspberry Pi rebooting. You can continue from the PUTTY interface if you want. That's one option, but I will do it more visual using VNC and will work directly over the Raspberry Pi desktop. So I will close this window. I don't need to use PUTTY for now. I just needed to use it to enable VNC. So I will start the PNC viewer, which is another software that you can download from the web. And I will open the PNC viewer. So this is my app IP address. You can type the IP address here if you want to. It's the same thing. So the first time that you connect, it will say that the identity failed. The identity check failed. That's okay. That's a security warning only. You can click on continue. And well, you can basically close those messages. We don't want to configure the Raspberry Pi right now. So you have access to the Raspberry Pi network from nothing. I didn't use a monitor or something connected with it more than the power cable. Okay, so here is where the real IoTView installation starts. So the first recommended step on the manual, and I really recommend you to do that, is to run these commands: the update of the repositories and the upgrade of the OS and the software installed on it. So let's do the update first, and it will update some repositories. So let's give it 30 seconds probably to finish. Okay, it finished, and now I will run the next command, which is the OS packages upgrade. And let's paste the command, and it will do an upgrade of all the, yes, I want all the packages installed on my Raspberry. So this will take some minutes, maybe 4 minutes, 3 minutes, depending on your internet connection and the Raspberry Pi version that you are using. It might take more or less time. So skip the video 2 minutes and see what happens after that. Okay, so we finished. It was a long process. I didn't expect that so long, but we are ready now. We can continue. So the next step in the guide is that we need to transfer a file from the development computer where AVEVA Edge is installed to the Raspberry Pi to the Raspberry Pi device. So we need to go to this folder, and I will access to the folder manually so you can see the full path. So it's in the C drive, it's in the program files x86 if you have a 64 bits OS. Um, it's inside AVEVA, it's inside AVEVA Edge, and inside Redist, and inside IoT View, Linux, ARM, GNU, blah, 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 this one. We are using an ARM processor, so I need to select this. If you are going to use Ubuntu or any other x86 based OS, you need to use this one. But the file that we need should be here. So here is the remote agent file. As mentioned on the guide, we need this file inside the Raspberry Pi. So if you are using a tool that allows you to do a copy and paste, that will be ideal. So inside the P home Pi folder, it's recommended to follow what the guide suggests, which is create a new folder inside this folder. And this folder name should be IoT View, all without capital letters. So, okay. And we have our IoT folder. So as I mentioned, you can just copy and paste this, but in most cases, well, you cannot do that. So there is an option. You can put the file in a USB drive and put the USB drive connected to the Raspberry Pi and move the file from the USB drive to this folder. But if you don't want to do that, there is another tool that is also free and you can find on the web, which is the WinSCP. So if you open this tool, it will allow you to have an interface where you can transfer files from one side to the other. So I will put my Raspberry Pi IP address here. And if I click login, I say update, username, Pi, password, Raspberry. So now I'm connected with the Raspberry Pi and I have my IoT View folder here. So I can go to the folder where I have my remote agent application, which is already here. And I can just drag and drop the remote agent application. And that's it. I don't need this tool anymore. So you can close it. I'm closing it. I click it on the Chrome button. Okay, so we have our remote agent application now here in the IoT folder. So what's the next step? In a terminal window, we need to access to the IoTView folder. So CD and IoTView, I will copy the command and I will open a terminal window here, which is already open. Let me just maximize this and I will paste the command. So we are inside the IoTView folder now. I'm following the guide. So let's go to the next command. This command converts the remote agent or changes the permissions on the remote agent so it can be executed. So let's do that. And it's done. So the next thing, the next step in the manual is execute the remote agent application. Okay, so the remote agent application is started now. And what we need to do is connect through using the AVEVA Edge. So in AVEVA Edge, in the project that we have created, we can click here in the Home tab on the ribbon in the Connect button. We should type the IP address for the Raspberry Pi. Click on Connect. It will connect with the IoT View, but it will tell you that the IoT View is not installed. So we need to install the IoT View. And to do that, you just need to click on this button. That's it. Installing IoT View will take not so long like the OS upgrade that we did some minutes ago, but it will take a couple minutes, maybe 3. So let's wait for that. You can skip the video, 2 or 3 minutes. Okay, so it finished with the files transferring. Um, if we do a disconnect and a reconnect, it will tell us that we are connected with IoTView version 20, service pack 1. Uh, as you remember, the previous message said that we were connected with IoTView, but it wasn't installed. So we are connected and it's installed now, but we didn't finish yet. So the next step here is go back to the Raspberry Pi. And if we follow the guide, okay, we connect, we transfer, install system files. We already did that. On the target device, press Ctrl C. The remote agent is stopped. So let's do that. Ctrl C. Okay, it's stopped. And the guide says, okay, run the installation script in order to finish the installation and configuration. Okay, copy and paste. And here I want to make a pause because as you saw, if I run the command, it says installation complete. If you see this, there is a problem. What you should see instead is a long log with installation processes running and configuration running, etc. So if you see just this installation complete message, that means that the installation failed. It's ironic because it says installation complete, but it was complete in an incorrect way. It failed to install everything that we need. So what this what this install sh file does is basically configure all that the guide says for the step number 10 and so on. So step number 10 or 11, blah, 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 16, 17, 19. All these steps are done automatically by the install.sh script. So if we open it with a text editor, we will see what's the content of the script. And what I recommend to do if you find that the script execution says installation complete is run the installation again, but with the script modified to force the installation of a patch, the installation initialization, and the configuration change. So if we set to 1 these variables, we will be forcing the installation to be done. So let's save the changes. We save the changes on this install sh, and we can run the installation one more time. So let's do that. Oh, see that we have something different now. It's trying to install a patch, which is the web server that we use for mobile access. So let's allow the installation of a patch. This process is quick. It should not take a lot. I already finished. So you saw that the installation did install a patch, configure a patch, configure other things, created the log, configure remote agent to run as a service. So all that was done, but it wasn't complete in the first try. We needed to modify the script to do that. That's important because sometimes it might fail, like in this case. So we are lucky that it failed because you can see what you should do if it fails. So after doing that step, what the menu says if the installation was complete successfully. In fact, the installation says if the installation script did not run successfully and cannot connect, the remote management tool cannot connect with the target device, you must continue with the following steps. But we don't need to do that because the installation was executed successfully. So we just need to reboot the device. So reboot. Okay, so we are back. The Raspberry Pi reboot. We need to close this and close this. And if everything was installed successfully, if you start the terminal, let me maximize this. If you start the terminal and you type this command, sudo service remote agent status, it will tell you that the remote agent is running as a service. So right now, without doing anything else, but that command that I executed was just to check if the remote agent service was running or not. But without doing anything else, the AVEVA Edge IDE will be able to connect with the Raspberry Pi. So let's do that, and we are connected. So now we are ready to send our project to the Raspberry Pi. So what I will do is, well, I want to disconnect this first. Yep. What I will do is, I will create a new screen where I will put a button to maybe increase the value of a tag. So I will create a tag called T1 is equal to T1 plus 1. So do you want to create T1? Yes. So T1 is created. I will put a rectangle here. So I can see the value of T1. Caption T1. I will make the font a little bit bigger. So yeah, that's fine. So T1. I will call the screen main. And since this is 2020, this is version 2020, the first screen that you save is the startup screen by default. If you don't want that, you want to create another screen and set it as a startup, you right click and set it as a startup. That's it. But this will be my startup screen. The next thing that you need to do is open the mobile access configuration here. Accept this message and check that enable CGI option is enabled here also. Configuration, if it is, well, that's fine. You only need to click on the save button. That's important. Even if you didn't change anything, you need to click on the save button. And that's it. The next step is that you need to save your screen to HTML. So it can be available through mobile access. And after that, you only need to download the project to the Raspberry Pi. Project, download, the project folder doesn't exist, that's fine. We can create it. And the application is being transferred. If your application is big, it will take a long time. If it's slow like this one, it will take some seconds only. So it's sent already to the device. So let's start the application and let's check the Raspberry Pi device. So the first thing that I recommend you to check is check the service one more time. So if you check the status, you will have now the remote agent and now also the IoT View process running. So you have both now, the remote agent and IoT View. If you remember in the previous checking of the service, only the remote agent was running. But now we have two processes running. The IoT View is the runtime, and that's what it's important to have running before testing the mobile access runtime. So if we start the mobile access, let me start the web browser here. I will maximize this window. I can go to localhost, which is localhost, MA index.html question mark screen equal main. I will be able to access to my mobile access interface. So if I click on logon, I have my button and I have my rectangle and everything works. So that's it. That's how you configure mobile access. You can even, and this is something additional, you can stop watching the video right now if you don't need anything else. But IoTView has some drivers, some communications drivers that at this date, we have some of the native communication drivers ported to IoTView. There is a list, but one of these is the mode TCP driver, the standard Modbus TCP. So I will add the mode TCP driver to my project. And just for the sake of demonstration, I will configure it to move to send into the T2 tag. The station will be my computer because I will be using a simulator. So get a computer IP. This is my IP address, but this is not my real IP address. I think it was one of my IP addresses. So check. So yeah, it's 17. Okay. So it's 117, port is 502. And the slave number is 1. And the station will be for X1. So that's the configuration for my mod TCP driver, Modbus TCP. And I will stop the runtime on the IoT view. If I stop the runtime, you will see that the effect on the Raspberry Pi, the mobile access runtime will be stopped too. So the clients will be log off. And I will start the application. No, I will download the modifications that I did. So it will connect with my simulator. Meanwhile, I will open the Modbus slave here, the simulator, and I will connect it. So disconnect, connect, Modbus TCP port. Yeah, that's fine. Yep, so it's connected now. And I will start my IoT view runtime. By the way, I forgot to add something on the screen to see the numbers. So I will add a text box here below. I will configure it to be T2. Save it. Publish to HTML. Stop the runtime on the Raspberry Pi. And download. And yeah, that's it. Let's start. So let's go to the Raspberry Pi and let's access to the mobile access interface. The value here is 0. You can change it back to 1, 2, 3, 4 maybe. And let's see in the simulator, you can see that we have 1, 2, 3, 4 also. We can change it here to 4, 3, 2, 1. And you will see in the IoT View runtime, we have the same value. So we can connect devices, we can connect MQTT, etc. We have an OPC server, we have an OPC client, have scripting options, very powerful tool. If you have plans to use it, I encourage you to test the functionality. If you find that something is not working as it should, just reach AVEVA support and the team will be able to help you. And that's it for now. If you have any comments, please leave that in the section below. Have a good day.